Welcome to Study Loop.
This is the answer to chapter 22, problem number 44. And we are asked to talk about why this amide is a stronger acid and a weaker base than this amine. And so the number of carbons are the same. Both the amide and the amine are primary. And so the only real difference is that obviously this is an amide, this is an amide, and this is an amine. And so the difference here is resonance, as I've written in green with an exclamation point. Resonance makes all the difference. So when we're talking about these two molecules in terms of their acidity, when we look at the amide, we see that if a base were to pluck a proton from the amide, we would get to this middle structure that I've drawn here. And this middle structure has a resonance structure where the negative charge is on the oxygen instead, and the nitrogen has a double bond to the carbon. And so since that negative charge can be stabilized by this resonance, this is a somewhat stable conjugate base of the amide as an acid. Whereas when the primary amine loses a proton, it doesn't have a resonance structure. And so its conjugate base is much less stable. And remember, that's one way to think about acidity in terms of the stability of the conjugate base. And the more stable the conjugate base, the stronger the acid. And so in this case, amide is a more stable conjugate base, or pardon me, the amide is more stable. Its conjugate base is more stable than the conjugate base of this primary amine. And so that means that the amide is a stronger acid. And so resonance is also the reason for the difference in basicity. So if we just draw this primary amide, acetamide, we can actually just draw a resonance structure just based on the starting structure, where rather than the oxygen double bound to the carbon, we have the nitrogen making a double bond with the carbon, and the oxygen only making a single bond. And they do each have a formal charge in this instance, but that's all right. This is a viable resonance structure. And what this means in effect is that rather than the nitrogen having this whole lone pair, oops, and that should not be there. So rather than this nitrogen having a whole lone pair to donate as a base, what it means is that some portion of the time the oxygen has the extra lone pair. And so the nitrogen is therefore less basic because it doesn't have really a full lone pair to donate. Whereas, again, the primary amine has no resonance structure. So for the primary amine, the lone pair is on this nitrogen all of the time. And so it always has that lone pair of electrons to donate to something to act as a base. And so really the differences between these two molecules come down completely to resonance. And that is the answer to chapter 22, problem number 44.